Hi everyone. Sorry I can't be there with you the day right before a test, but the world continues to turn and doesn't stop for anyone, and the only appointment I can make is today, and so it is what it is. But I trust that with your expertise, your practice, your hard work, that you're not going to let the absence of some due that you're not going to see again in another 3 months, it's going to get in the way of your progress and your success. And so, um, Godspeed and suffer well. I know you can do it. It's already been unlocked. Today's video solution. I am assuming that you've made an attempt at it already in class. But if you are watching this just because you want to see it done already, that's fine. Once again, it is under Chapter 2, Application and Tangent Questions. There's extra extended A&T style questions that I think will be really helpful. Why is it helpful? If you are right now what I'm going to call a victim to these cookie cutter mold questions where, here, what's the tangent line to a curve? And all you had to do until now was sort of follow this formulaic, step by step kind of thing. I'm going to challenge you to do every single one of these because it forces you to break out of that mold. And it would be a shame for you to be rigid in calculus because the application of calculus is so fluid, it's so flexible. Okay, so I handpicked question 2, 5, 8, 10, 16, and 19 because they look different. I purposely did it because they look different. Now, specifically for, let's say, question 10, it looks like there is a combo derivative. You do not have to worry about combo derivatives in the test, but might as well just do it here, okay, just to show you. So starting off once again, this might be a little fast. I'm assuming you tried it, but if not, more than copying what I'm doing down, just try to listen. I think that's most important. It'll probably take about 30 minutes as a video, and so here we go. A tangent line to a curve at x equals 2 passes through the points this and that. So wait, the tangent passes through these points. Interesting. What are the values of f of 2 and f prime of 2? Well, just to give you a visual, 0, -20, and 540, these go through the tangent, which means I can actually use these two to figure out what the slope is. And what is a slope? It's f prime. So indirectly, I actually gave you an easy way out. The slope of the tangent is y2 over x2 minus y1 over x1. That's -60 over -5. That is +12. Guess what? The slope at any point on this tangent is going to be 12, which means it also includes f prime at 2 is going to be 12. They are one and the same because I am talking about the tangent at 2. All right, which leads us to what is the y value when they don't even give you the function? How do we solve it? Well, let me figure out the equation of the tangent first before I explain myself. Okay, y is equal to mx plus b, and I'll choose any of these. Specifically, they already give you the y-intercept, so I'm not even going to calculate it. It's 12x minus 20. This line, let's pretend it's something like this. That's the tangent. Lo and behold, I don't know what the function is, but when x equals 2, right here, when x equals 2, that point also coincides or is a common point between my curve and the tangent. Like, that's the whole point, the tangent at 2. So if I could figure out the point on the tangent at 2, I have figured out the point on the curve at 2 because it is one and the same. You get me? So I'm going to use this. What is the point on the tangent when x equals 2? It will be 4. That also happens to be the same point on the curve. Done. Check it out. Question 5. Here's a fun one. Determine the value of the constant. It's a constant, so some real number, so that the line y equals 4x minus 1 is tangent to the parabola. Okay, so this is supposed to be tangent, then the slope of this tangent must be the same as the derivative, whatever the x value might be. Okay, so let's check it out. I am going to do dy over dx, which is 2x plus 0, because k is a constant, and that has to equal a 4. Oh, well, that's simple. That means we must be talking about x equals 2. Right? So, once again, y is equal to 2 squared plus k. That's my y value. But here's the thing. Once again, just like question 2, the point on this tangent is the same point on the curve, right? At 2. So y is equal to 4 times 2 minus 1. The point on the tangent, 2, 7, is also a point on the parabola. Okay then. So y is equal to x squared plus 7. Well, I just said 2, 7 is a point on the curve. So that's 4 plus 7 plus k equals 7. K is equal to 3. Done. Moving on. All right, did I have to do anything else? Determine the value of constant k. That's it. Find a cubic function. Ooh, this is a long one. This is a long one. Find a cubic function, and what's a test without a t question with multiple variables like this? Here's a standard form, sort of, whose graph has horizontal tangents at the points here and here. What does horizontal tangents mean? That means f prime at -2 equals a 0. And also f prime at 2 also equals a 0. That's what horizontal tangents mean. Oh, well, that's nice. This actually gives us some unknown equations. But here's the thing. Even before starting, I'm expecting the worst. I have 4 different variables or 4 different unknowns that I need to identify. What does that mean? Potentially, I might need 4 different equations. And that's going to be fun. Let's try it. Here we go. I've just talked about this, and they gave it to you right in your face. So let's try it. F prime of x is equal to power multiple constant rule, 3ax squared plus 2bx plus c plus a 0. Nothing. Using this, let's work on it. F prime of -2. -2 times -2, 4, 3. 12a, -2 times -4b plus c equals 0. And we'll call that 1. For the next one, when x equals 2, 2 times 2 times 2, 8, 2 times 2, 4 times 3, 12a, 2 times 2, positive 4b plus c equals a 0. Let's call that equation 2. All right? And I'm sure there's more, but should I keep going? You know what? Let's figure out where other equations might come from. What you didn't know, or what maybe you were distracted from because of the equation, the horizontal tangent business, is that they actually give you xy points on the function. So in fact, if you go back, you actually have something more. We have f of -2, which is -2 cubed, -8a, -2 squared, positive 4b, plus -2c, -2c, plus d. That is equal to 6. And f of 2, which is 2 cubed, 8a, 2 squared, 4b, 2c, plus 2c, plus d is equal to 0. From here and here. I got 4 equations. Yay. Let's see what we can do. See if we can finesse this, because I'm already seeing some things we can cancel out. Look at this. -4, positive 4. I am going to add both together. I have 24a plus 0 plus 2c equals 0. Let me bring it to the other side. 24a equals negative 2c. Dividing both sides by negative 2, I have negative 12a. Would you look at that? If I know what c is, I know what a is. And if I have a, then I have c. Okay? This is cool. I'm actually going to take this and plug it back in here. I have 3 equations, but take a look. If I plug in 12a, so this is equation 1, 12a minus 4b plus c equals a 0. But what is c? C is negative 12a. So if you cancel that out, 12a, negative 12a, I've got negative 4b equals 0. What does b have to be? 0. We figured one out already. Great. What does that imply? That equals a 0. That equals a 0. Because that's a 0. That is true. And that is true. Wild. Let's work on 3 and 4. Negative 8, positive 8. Perfect. I am going to jump the gun, and that's a 0. That's a 0. 2d equals 6. Oh my goodness. This question is just giving me gifts. D equals 3. I've got another one. Okay, so I've got that. And just because I've got that, if I have D, I can plug it in. I have A and C left, but remember, I can substitute that as well. So taking 3, I have negative 8a minus 2c plus d equals 6. Negative 8, positive 24. So negative 8 plus 2, positive 16a equals minus 3, minus 3, 3. So a equals 3 over 16. Amazing. And moving on, now that I have a, bring it back to this relationship. Negative 12 times a is equal to c. So what is c? C is, let's see, that's a negative 3 over 4. Negative 9 over 4. Done. I mean, yeah, it's got fractions, but we don't have to do anything with those fractions. We just leave it there. So what's wrong with it? Okay. So again, this might be a little bit long for you to copy. So instead, see that it is totally possible, and all it is just simple substitution. Please try this on your own. Number 8 is a great question. It's a really fun one once you get it done. Okay, feel proud. Question 10. Here's a good one. Again, you don't have to go to this point, but you should understand the concept and not be frightened when you see something like this. The only challenge is that this is a combo derivative where I have to do a quotient rule, but in that quotient rule, there is a product rule. All right, so don't be too scared. I'm going to write this down. And yes, as a reminder, you do not have to worry about combo derivatives of this sort on our test. More exercises will come in the future. F prime means derive the first, leave the second, minus leave the first, derive the second, all over this squared. So if I'm going to derive the first, I need to do product rule and I need to do constant rule. So we have derive the first, leave the second, plus leave the first, derive the second. I derive that, plus 0, so I'm not going to write it. Multiply that by the bottom denominator, minus leave the numerator, derive the denominator, all over denominator squared. Okay? And I'm not going to simplify any further because the question literally just asked me to plug in a 1. We've got 1 times g of 1 plus 1 times g prime of 1. All of this is multiplied by f of 1, subtracted by 1 times g of 1 plus 7 times f prime of 1, all over f of 1 squared. Let's see if we can simplify this. G of 1, 1. G prime of 1, minus 2. f of 1, 1, minus g of 1, 1, plus 7, f prime of 1, 4, all over f of 1, 1 squared. Simplify this, I have negative 1 times 1, negative 8 times 4, over 1. The answer should be negative 33. Just a quick cheat. I'm going to check the answer key. Number 10, negative 33. Great. Okay, so once again, don't be afraid. Try the other questions, like question I think 9 gives you the same thing, but it's not too strenuous. It uses power rule with quotient, not just product rule within a power rule, within a quotient. Okay, give it a shot. Question 16 is a fun one. The line y equals 1x plus 1 is tangent to the graph this at x equals 1. It is also tangent to the graph at a second point. Find the 2 points of tangency. Okay, so looks like it's a cubic and it's upside down. Maybe something like this. And x equals x plus 1. So a line like this is tangent at 2 locations. So let me fix that. Maybe it's something like this, and x plus 1 is a line and it does that. So it's tangent at 2 different locations. Something along like that, along those lines. I need to find that second point. X equals 1 is one of them. What's the second one? Okay, let's break this down. Firstly, the derivative dy over dx equals negative 4x cubed plus 4x plus 1. The slope, when x equals something, the slope has to equal a 1 because the line tangent to them is 1 plus 1, 1x plus 1. Okay, so let's figure it out. One of the x's that I find should be a 1, and I should find a second point. Here we go. We've got, so let me take this and rewrite it. Negative 4x cubed plus 4x plus 1 equals a 1, which means negative 4x cubed plus 4x equals a 0. Oh, that's nice. I'm going to factor negative 4x. That leaves me x squared minus 1. That's even nicer. So you know this is difference of squares. If I want this to be true, x could equal a 0, and here x could equal a positive or a negative 1. Ooh, problem. I see 3 possible x values, but the graph said it's only 2 points. So one of these is a bit of an imposter. Interesting. Okay, well, let's try it. I'm going to go to the points we've always made before. If a point on this graph has a tangent equation of this, that means a point on this and the point on this, they should be common. Whatever I find at x equals 1 should also be found at x equals 1 here. They should be on the same. They should be the same point because they're tangent. Okay, so let's do it. Why? When x equals 1, so the point that's given, that would equal 1 plus 1. The point is 2. So 1, 2. Does that exist on my curve? Let's try it. So tangent and curve. Y is equal to y at x equals 1. That is equal to negative 1 to the power 4 plus 2 plus 1. That is a 3 minus 2. That works. So I know that they were telling the truth. Let's try the 0. Tangent. Y at x equals 0 is 0 plus 1, which is 1. So the point 0, 1 is on the tangent. On the curve, y at x equals 0 would be negative 0 plus 0 plus 0. That's a 0. Ooh, they do not agree. So x equals 0 is my imposter. And let me tell you why that shows up anyways, even if it's an imposter. And just to confirm, on the tangent, y when x equals -1 would be -1 plus 1. That's a 0. So -1 comma 0. Okay. On the curve, y when x equals -1 would be -1 to the power of 4 plus 2 -1 squared plus 1. So that would be -1 plus 2 plus 1. That would, wait a minute. Am I doing something wrong? Oh, that would be a -1, sorry. -1, so that's a -1. So that would be a 0. Okay, so -1, 0 does agree. So the 2 points that I'm looking for, the second point of tangency is x equals -1. Why does 0, 0 pop up? Let's go to Desmos. On Desmos, we've got, let's see, y equals x to the power of 4 negative plus 2x power of 2 plus x. Okay, and here's the tangent. The tangent is at 1, 2 and at -1, 0. The reason why it shows up at 0, 0 is because, look at the slope. The slope is still 1. It's the same slope as this point and this point. So the derivative, when you set the slope to equal 1, gave you all the tangents that have a slope of 1. So you will have to do a little bit extra work, or just be cautious to make sure that it's not an imposter, right? The tangent line is y equals just x. Dun, dun, dun. All right, that's a fun one. 19. Two tangents. So this is, I was a little hesitant to write, but I left it in the Google Doc. Try it out. Two tangents drawn to the parabola here from 0, 0 are perpendicular. So again, let's pretend I have some kind of parabola. I don't know what it is. Something like that. Okay. Two tangents drawn from 0, 0. So maybe it's like that, and maybe it's like that. These two tangents are perpendicular to each other. Find it. Ooh, let's do it. Ready? Here we go. First off, dy over dx is equal to 2x plus b. The slope given here is going to be, whatever that might be, the two tangents, it's going to be negative reciprocals of each other. Now, if you remember one of the questions we've done where we are finding a tangent that crosses a point not on the curve, we had to pretend there was a fake tangential point. So let's pretend, let a and then a squared plus ab, a squared plus ab plus 1 be a tangent point. Okay, that's it. So basically we're making x equal a. This is my tangent point. What does that mean? It means my slope is also going to be 2a plus b. So here we have our equations. We've got slope equals y2 over x2 minus y1 over x1. And that is a squared plus ab plus 1 over a minus minus 0, 0. And the slope is equal to 2a plus b. All right? So minus 0 is nothing. So I'm going to take this part and turn it into an equation. A squared plus ab plus 1 over a is equal to 2a plus b. But since I'm going to multiply both sides by a, this becomes 2a squared plus ba. Let's turn it into a single equation. So we have, bring it all over to one side to make it make the other equal 0. I am going to subtract both sides by a, which gives me a squared. Subtract both sides by ba, which means 0, and subtract both sides by 1. Well, would you look at that? 0 is equal to a plus 1, a minus 1, so a equals negative 1 or 1. There's my 2 points. Where did we go from there? Well, we found the a value. That means we can find, sort of, the b value. It's not quite easy, but we can try. So if a equals negative 1, that means, so my x value would be negative 1, and my y value would be 1 minus b plus 1. 1 minus b plus 1, y value is negative b plus 2. If a equals 1, so that means my x equals 1, my y equals 1 plus b plus 1. 1 plus b plus 1, so b plus 2. So there are my 2b points. I don't know what they are, but here's a clue. The slope at a equals negative 1, or x equals negative 1, and slope at x equals 1 have to be perpendicular. So what is a slope? Remember, slope, or rather y prime, is 2a x plus b. If x equals negative 1, that's my slope. If slope equals positive 1, then I have 2 plus b. These two values have to be perpendicular to each other. So we have negative 2 plus b is 1 over. So if this is perpendicular to that, this has to be equal to negative reciprocal of that, right? Yes. So I'm going to multiply both sides by 2 plus b, which gives me b squared minus 4. That means b squared equals 5. B equals plus minus root 5. Ho, ho, ho. That's why I'm wondering if this was a little too hard. But it's good. It's really, really going to stretch you. The question is asking for the equation of the tangents. So we have, let's see if we have all the pieces. I have the slope. Remember, if a equals 1, that means the slope is 2 times 1 plus 5. And then, or plus root 5 or minus root 5. And then we have, oh man, maybe I should have done this ahead of time, because I'm starting to get a little bit frazzled or trying to keep up with everything that I have. Let me see if I'm doing this correctly. 2 tangents. Let me give me a pause. Okay. I took a minute to think about it, and yeah, I think we're on the right spot. The reason why we have 2 possibilities is because b, being a variable, I don't exactly know where the parabola is. Is it this, or is it, depending on where the b is it going to be down here so that there actually is no correct there's all these different situations going on. So let's put it this way. If a was 1, right, we could have either this or that. But know that if the b value is fixed to be positive root 5, then the y's for, if a is 1, the y would be 2 plus root 5. And if a is negative 1, the y would be negative 2 plus root 5. If the b value was negative root 5, then the other point would also have to be negative root 5. There's actually two sets of answers based on what b could be, and they both satisfy. Each value of a gives me a two separate values for b. In other words, there are two sets of tangents that could be drawn. Maybe it is too hard after all, right? But I think it's a good exercise. Really mull over it. If you're up for a challenge, try 19 on your own. Of course, try question 20 or whatnot on your own as well. They are considered, I think, a little too hard, which means you won't have to worry about it, right? But it's great exercises. In the least, would you please consider or challenge yourself up to question 15, because they would be a level of questions you might have seen if our test wasn't shifted so much. Get what I mean? So push yourself anyways. Like, what makes you any lesser than the students who came before you or the students who will come after you, right? Challenge yourself. And if you have any questions, email, of course, and otherwise, suffer well, and we'll see you when I get back.